Welcome back for part 3 where we are going to look at how to calculate areas. We're going to use a PV array as an example, but this can apply to roof spaces and ground areas as well. The formula for calculating the area of a rectangle is length times width equals the area. The key here is that this needs to be the same unit of measurement on both the length and the width, but it works for any unit of measurement, be it feet, meters, inches, millimeters, centimeters. As long as the units are the same on the length and the width, you will get the area of that rectangle. In this example, we have an array that is 41 feet wide and 16.5 feet high. We get 3 rows of modules. We can see that 16.5 feet is in a decimal as opposed to 16 feet 6 inches. We converted the 6 inches to half a foot and we get 16.5 feet so that the two dimensions have the same unit of measurement. When we multiply those two, 16.5 feet times 41 feet, we get an area of 676.5 feet squared. We could do the same calculation if we had meters. If we had the meters, the length times the width, we can multiply those two and we get square meters. If we had inches, we'd get square inches, millimeters, square millimeters. The formula works the same as long as the two units of measurements for the two sides are the same. This also works for parallelograms. So if we had a roof where the side was at an angle, as long as the two sides were at the same angle, they were parallel, and the dimension of the two sides are the same, this same formula would work, because essentially what you've done is taken a rectangle and pushed it over to its side. As long as the sides are the same measurement, the area inside that parallelogram is still the same. Now, the area of a triangle can be calculated by taking the base, multiplying it by the height, and dividing by 2. That will give us the area. The interesting thing about a triangle is if you take the triangle and duplicated it and spun it 180 degrees, you will get either a rectangle, as we see on the left-hand example with this right-angle triangle. If you duplicate a right-angle triangle, spin it 180 degrees, you get a rectangle. With this triangle on the right that is not a right angle triangle, if you duplicate it and spin it 180 degrees, you will get a parallelogram. So we can take the base times the height, divide it by 2, and we will get the area of the triangle. If we take the right angle triangle, the base is 12.3 feet, the height is 10.4 feet. We multiply those two and then divide by 2, and we get the area of the triangle, 63.96 square feet. Now with the parallelogram, we take the 14.7 foot, that's the dimension of the base, and we don't take the side of the parallelogram. We're not interested in the length of the side. We want to know the height, and that goes from the base to the point of the triangle in a vertical line. In this case, it's 11.9 feet. We multiply that 14.7 feet by 11.9 feet, divide that by 2, and we get 87.47 square feet. When we're doing this calculation, we have to go back to PEMDAS, our orders of operations, parentheses, exponents, multiplication, division, addition, and subtraction. We look in this formula, we have no parentheses, we have no exponents, so we go to multiplication and division. And we have to remember that since there are no parentheses here, we're going to go from left to right. So in the case of the right angle triangle, we're going to multiply the 12.3 by 10.4 first, get the result of that calculation, and then divide that by 2 to get the proper area of this triangle. If we did it in a different order, we might get a different answer. So make sure we're remembering our order of operation and how we're going to do that calculation. Always go from the left to right unless there is a parenthesis or an exponent in that formula. Okay, that's the end of this section on calculating areas. In the next part, we're going to talk about the differences between power and energy. So join me for that when you're ready. Thank you very much.